preparation for your igcse exams, I have prepared this agenda list for today, and we're going to be running through all of it super duper quickly. Okay, first things first, let's take a look at halogenation. So this is basically halogenation of alkanes. Now, chlorine and bromine react with alkanes to form a mixture of the products, and the reaction requires ultraviolet light to produce activation energy. So if you'd say methane plus chlorine, since chlorine is diatomic, one of the atoms of chlorine will substitute one of the hydrogen atoms in methane, and the other chlorine atom will form hydrochloric acid with the HCl that has been kicked out of the methane. Again, the only requirement for this reaction is ultraviolet light or UV. Okay, next we have addition of bromine. So this is basically halogenation of alkenes. So in this case, we will be adding bromine to an alkene. Let's say we have ethene. I'm sure you guys know the structure of ethene, and if you know the general formula, that will be C2H4. If you add that to bromine, the double bonds will open up, and this will basically form 1,2-dibromoethane. Dibromoethane. So, the double bond in between both the carbons will open up at the end to form a bond for bromine. As we know, bromine is diatomic, so both the atoms of bromine will be at each end of the new formed compound. Now, this reaction is very useful to identify the presence of unsaturation in organic compounds. Unsaturation is basically when there is at least one carbon to carbon double bond or triple bond. So there has to be one less than a carbon to carbon single bond. Now, there's also combustion of alkenes. I haven't written down over here because it is basically just the same as alkanes. Now we're going to look at addition of hydrogen. This is going to be for alkenes. So, as my previous example, I'm going to take ethene and we can add hydrogen to it. That will form ethane because the double bonds in ethene open up, and on each end we have a new hydrogen atom, and we do know that hydrogen is diatomic, so there'll be two more hydrogens, hence it'll give us the general formula of an alkane. Now there are certain factors that are needed for this reaction, like nickel catalyst, and there has to be heat present. For your syllabus, there should be 150 to 300 degrees Celsius for this certain experiment. Okay, next we have addition of steam. This is basically kind of known as hydration. So this reaction, let's use ethene again. If we add water to it, but in this case that water, H2O, is going to be gas because it is steam. So H2O gas added to ethene will give us an alcohol, which is ethanol. And if you don't know the general formula of an alcohol, it is CnH2n plus 1OH. And this reaction requires 300 degrees Celsius of temperature. The pressure should be 60 to 70 atmospheres, and the catalyst is phosphoric acid. Now, I did think of adding a little tip over here by giving you the uses of the two methods of addition of steam. So, the manufacture of ethanol can be done by fermentation of sugars and addition of steam to ethene. We did look at the addition of steam, and let me just quickly give you the advantages and the disadvantages for addition of steam to ethene. Okay, first things first, this is very fast, and it is a continuous process. It does give a high yield, and the disadvantages include high energy needed because 300 degrees Celsius is not a low amount of energy or low temperatures. It is non-renewable, and there are limited resources as this requires ethene, which is obtained by cracking. Next, we have fermentation of sugars. So these are basically enzymes in yeast that are used to convert sugars into ethanol. And the reaction requires anaerobic conditions, so basically no oxygen. And this is basically the C6H12O6. And basically, enzymes in yeast are going to be able to give you ethanol and carbon dioxide. Now, the advantage for this is that there's low energy consumption because it requires only room temperatures, so like 23 to 25 degrees Celsius, and renewable materials are used. However, the disadvantages are that it is slow and it's not a continuous process as batch production has to be done, and it has less yield than addition of CM2 ethene because it has only a 15% yield, and it is not completely pure because it does have to undergo fractional distillation. Also, before I forget, the uses of ethanol include fuel. It's used as a solvent, especially in perfumes, and it's used to make many organic compounds, including esters, which we will take a look at later in another video. Okay, now we're going to be um, adding oxygen to ethanol, so basically oxidizing ethanol. And that will make the reaction be an alcohol to a carboxylic acid. Right? Now, the reaction between an alcohol and a carboxylic acid is what esters are called. And again, we'll take a look at it in a future video. However, in this case, we're turning an alcohol into a carboxylic acid. Now, ethanol can be oxidized to ethanoic acid in two ways. There's only one required for your syllabus, however, knowledge is not harmful. So the first method, which is required and mandatory for your syllabus, is using acidified potassium manganate 7. And when a mixture of ethanol and, let's say, acidified potassium manganate 7 is heated in the reflux apparatus, ethanoic acid is formed. So the purple color of the manganate 7 turns colorless. And a reflex apparatus is connected to a condenser to prevent loss of volatile reactants or products. So all you need to know for this is that the solution turns from purple to colorless. Right, next is by using acetobacter bacteria. And these bacteria are basically found naturally in air and on many surfaces. So they basically just use oxygen in the air to oxidize ethanol into ethanoic acid. So this basically explains why wine turns into vinegar when exposed to air. The reaction is ethanol plus oxygen, obviously, with bacteria on the arrow, gives us ethanoic acid and water. Okay, that is it for today's video. I hope you guys are taking notes because I didn't have time to type all this down. But yeah, I'll see you in the next video.